Wireless LAN Professionals Podcast, episode 110.
Wireless LAN Professionals is a place to educate, inform, encourage, and entertain those involved in wireless LANs. This Wireless LAN Professionals podcast is an audio manifestation of these goals. Our host is a wireless LAN veteran, consultant, designer, and teacher, Keith Parsons. And now, the podcast for wireless LAN professionals by wireless LAN professionals.
Our first interview that I have today was with Steve Leytus. He's with Nuts About Nets, and we're going to talk about a product he has that I actually have fallen in love with. It's called Wi-Fi Metrics. Next up, we have Cate doing an interview with Nolan Wi-Fi, reviewing that blog. We have a 10 talk from Adam Vasquez on the ABCs of a wireless engineer's journey. And finally, I do a little tool review. This one happens to be on a tool I like to use called LAN Scan Pro. Enjoy this episode.
Main session.
Welcome back. This is Keith Parsons with Wireless LAN Professionals Podcast. And today I'm here with Steve. Did I get this name right? Leytus or Leytus?
Leytus is close enough, but really it's Leytus.
Leytus. Okay. Leytus, I can say Leytus. It's not one of those crazy ones. And you're with Nuts About Nets. We want to talk about your new product called Wi-Fi Metrics. I love the product. I think it's a great tool. But in order to get there, let's start at the beginning and let's talk about where did Nuts About Nets come from?
Okay, one of my favorite questions, because it turns out, when you tell people the name, half the people get it and half the people don't. About 12 years ago, when we started the company, when my kids were little, I gave them a number of names to choose from. And they thought Nuts About Nets was funny. And so I decided to go with that. And I think the other reason is because, there's a lot of things in life that are serious. When we were starting the company, I didn't want, troubleshooting wireless to be so serious. And so we intentionally, decided to go with a name that was a little bit more lighthearted.
Well, it's easy to remember. Yeah. It is kind of fun. So you met your goal. Nuts About Nets. Love it. So how did you start? What was you have your own company. You're sitting there in your house going, I think I should make a product. The product's going to be, and what was your first product?
So the first product actually was called Air Sleuth. It's a 2.4 gigahertz R spectrum analyzer. It used, I don't know if you remember, do you remember the home RF technology?
Oh, a long time ago, yeah.
A friend and I, we were changing careers because we were both middle-aged and having a hard time finding a job, and we went back to learn more about networking, wireless networking. As part of a class project, I stumbled on these home RF PCMCI cards, and I found that I could reverse engineer them to program them to scan a spectrum. And then I found a warehouse in Los Angeles that had a couple thousand of them that I could purchase for $1. And so the combination was you know what? Maybe we can make a product out of this. And so Air Sleuth was our first product, and it came out toward the end of 2006. It turned out that you probably heard of MetaGeek and Wi-Spy, and about a month before we were about to release Air Sleuth, MetaGeek came out with Wi-Spy, and it took a lot of wind out of our sails. Anyway, that was our first product.
I got involved the first time I saw Air Horn. It was like a physical manifestation of a Queensland attack that you could buy. I thought it was wonderful. A Wi-Fi chip to basically become a jammer. I don't know if that's why you made it, but that's how I used it.
Yeah, by the way, we don't call it a jammer because we could get in trouble for that. So it's
a noise generator.
It's a packet injector.
A packet injector. Other than it's not actually doing packets. Well, I guess it is. They're just not, is there any real payload in there?
These are garbage packets, but they are, the original Air Horn, they were 802.11b garbage packets. And then when we came out with a dual band, it was 802.11a garbage packets. But they really are packets.
Obviously, it's not totally obeying 802.11 because it doesn't do the listen before talk really well.
Actually, it does, and that's what led to the other product, Wi-Fi Probe, the one that actually tests the quality of each channel and uses that as a metric. It uses CCA or CSMA, CA, and it turned out that because air horn really is a Wi-Fi, it really follows the protocol. And early on when we were using air horn and testing it, these were the days when 2.4 gigahertz phones were common use. I remember we were testing air horn and everything was great and we we're going to release the product, and somebody made a phone call and all of a sudden air horn cut out. And we thought, great, we just destroyed our product.
Oh,
and then we realized
it was doing listen before talk.
Yes,
the CCA energy detect was tripped.
Yes.
Yeah.
So
I'll have to try that experiment with my air horn and see if I can make it stop that way.
Well, so actually now with the new Wi-Fi metrics device, because we have access, low-level access to the chip, the air horn functionality, we programmed it to sort of ignore if there's energy detection. So you may, if you hit it with a strong RF signal, you might be able to cut it out, make it cut out, but it would be more difficult than the original USB version of air horn.
Oh, I've got an old air horn that gives me a little experiment to try.
Yep.
So for Nets About Nets, who's your target market? Who you want to, what's a typical buyer of your products?
One of the things that we realized early on is that, look at what we came out, our first product came out at the time where air magnet was sort of the standard. And they definitely captured the upper end because their product was $4,000 or so. And then with MetaGeek coming in around 500 to 1,000, we also didn't want to compete with them. And so we decided that we were going to go for the low end market. We were targeting savvy amateurs and also professional installers who didn't want to shell out hundreds of dollars or thousands of dollars to do spectrum analysis. So for troubleshooting RF, our target audience are savvy amateurs, professional installers who basically are trying to solve an RF interference problem. And let me just add, this is sort of not to change the topic, but the other area that we're really interested in is wireless pro audio, because in the wireless pro audio field, they sort of have to deal with the same type of problem. In wireless pro audio, when they set up a live event, an audio engineer has to assign transmitters to different performers, and the frequency that they assign, it can't be interfered with by some digital TV station or some other RF going on in the arena or in the auditorium. So they are also using spectrum analysis to figure out where the open space is, what frequencies they can use to assign to transmitters. And so it's sort of like they're also trying to solve the same type of problem. So our tools sort of address those two types of audiences: people trying to troubleshoot Wi-Fi and people trying to troubleshoot wireless pro audio.
So does that pro audio also using the same frequency, same unlicensed bands that Wi-Fi uses?
No, it's a different radio. They're mostly in the UHF around 470 to 700 megahertz. So with the new Wi-Fi metrics device, they would not use that. They would use a spectrum analyzer like RF Explorer.
So you have products that span both.
Yes. So RF Explorer is not we're primarily a software development company. About 5 years ago, RF Explorer was handed to us on a silver platter. RF Explorer was developed by Ariel Rojo, who's the most amazing RF engineer on the planet. He's in Spain, and his team designed and developed the RF Explorer device, and it's manufactured by Seed Technology in China. And the compelling feature about it is a true spectrum analyzer. It's also very low cost. It supports a number of different frequency bands. And so for wireless pro audio, we write software for RF Explorer that helps to troubleshoot Wi-Fi problems. But Wi-Fi metrics is strictly for troubleshooting Wi-Fi.
When you were thinking of Wi-Fi metrics, how did you expect I know how I use it, but I'm probably not your typical user. What did you expect a normal user of Wi-Fi metrics to use it for?
I think that there are two main types of users. There are people like yourself who want the air horn functionality, where you have a standalone device. You don't have to associate with an access point, but you can generate some traffic to stress test a network, or maybe you want to test some Wi-Fi, some 2.4 4 gigahertz or 5 gigahertz antennas, and you need some sort of source so that you can test things. And so that's one main group of people. But the other feature that's most interesting to me is, and that's the Wi-Fi Pro feature. What's unique about it is that the whole goal, like for most people when they're installing a Wi-Fi network or when they're troubleshooting one, is like the main thing is like, what's the best channel? There are all kinds of sophisticated tools and metrics and stuff like that. But in the end, the way that like 80 or 90% of the problems are solved is that people wind up switching to a different channel. The next time Comcast or the cable people come to your house to fix your Wi-Fi network, the way that they always solve it, I mean, I've talked to many of them over the years, is that in the end, they wind up just changing the channel. And that solves the vast majority of problems that people run into with their Wi-Fi network. So the goal of Wi-Fi Pro is it uses a Wi-Fi chip to actually test each channel and rank each channel from best to worst using in the eyes of a Wi-Fi chip. That's what we hope will attract people to the product because it's very unique. There's no other instrument out there that uses a Wi-Fi chip in this way to actually troubleshoot Wi-Fi.
So is it actually sending data frames as it's scanning through the channel, or just listening on the channels?
It's just like air horn, except that it does it more gently. What it does, it traverses each channel. On each channel, it attempts to transmit a fixed number of bytes, but it can count how many bytes it successfully transmitted. So the metric that it displays is the number of bytes transmitted per second. Okay? And if a channel is clear, and it compares that to a reference. So let's say the reference, let's say in a vacuum, where there's no RF interference, and you attempt to transmit on channel 1, suppose the best you can do is 1,000 bytes per second. Okay? So now you go out into the real world, or you go into your office, and you do the same test, and it comes back as 800. So now the metric reports that it's 80%. So in other words, that channel has 80% availability because 20% of the time it had to back off because the CCA threshold was exceeded. So it traverses each channel, it attempts to transmit on each channel, and it counts how many bytes it successfully transmitted within that second, and then it reports that as a metric compared to a reference.
So how did you fake out the chip to not have to actually be associated in order to send data frames?
There used to be a chip company called Leytus. I don't know if you recall them. They were later purchased by Atheros, who was later purchased by Qualcomm. And it all has to do with the driver. Inside the driver, there is code that, so 802.11 doesn't require that you have to be associated before transmitting. Although I'm not intimately familiar with the standard, but I'll bet you $1, there's nothing in there that requires that you have to be associated before you can transmit.
Actually, there's something called the state machine that goes through different states, and different types of frames are allowed depending on where you are in that process. But I'm sure that at the driver level, you can ignore those.
Yeah. Okay. So we know from looking at the drivers, like especially for Linux, we don't have access to the driver code for Windows, but for Linux, there really is code that, like if you want to try to transmit but you're not associated, it just says nope, and that function returns. But if you have access to the right APIs, you can, and also if the driver allows you, you can. At least you used in the early day, back in the 2010 Windows drivers days, you could convince a driver to go ahead and transmit. Nowadays you couldn't. Nowadays the Windows drivers are too sophisticated, and for security reasons you can't do it. And so unless you're in the field of you have the capability of writing Windows drivers, we could no longer do that. And that's one of the reasons why we also migrated to our own device, where we had control over the firmware, and we could talk to the Wi-Fi chip directly. So then we could do basically whatever we wanted.
So that's that. I was wondering when I was watching it work, I'm like, how is it sending data frames when there's nothing to be associated with? And yet, so you're basically making the CCA process happen on a channel of your choosing.
Yes, that's it. It's embarrassingly simple.
But no one else can do it. So that's it. That it might be simple, but it's a neat trick, and no one else thought of it.
Oh, thank you.
Have you heard of something called Channel Fly from Ruckus?
Say that again.
There's a feature from Ruckus APs called Channel Fly, and Channel Fly kind of does the same thing you're doing, but it's on their AP, so they obviously have control over it. And they take statistical samples to find what's the best channel for the AP to move to, and then try to get all their clients to move to it as well. But it's a more complex question because it's trying to find, of all channels, where should I go, and then every AP will be, chasing each other's tail. Whereas your Wi-Fi metrics just saying, for me in this room and my house right here, what's the best channel?
Correct. And there are. So I'm not claiming that there aren't other. I mean, some of the higher end APs, there's things called like DCS, dynamic channel selection, and they have their own proprietary algorithm for how they figure out what the best channel is. And some of them may use CCA, or they may count. I know, like with Broadcom, they also take in that they count the number of access points that happen to use a particular channel, and that's part of their metric. But nobody really knows exactly how it works. And so, but depending on the environment, that may be desirable. Is that let the access point choose. But in other situations, it may be desirable that you want control, and maybe because whenever it switches channels, there's a price to pay. I mean, there's always a trade-off, right? You don't want to do it in the middle of the day when you got like 30 clients associated, because there's going to be a certain period, because those clients are going to drop off, and then they have to refind you. It might be that you have to do it 10 times a day, or maybe you just do it. You find the best channel at 3 o'clock in the morning. Every situation is a little bit different. The goal with this tool was, to at least provide the installer or the technician or the savvy amateur, tool, so that now they have some data that they can use when they're trying to troubleshoot. And if they want to change to a better channel, at least they have a clue what a better channel would be. And
some statistics to back it up.
Yes.
Have you noticed when you run this Wi-Fi probe that does it change much based on time of day?
I wouldn't say that it changes time on based on time of day, because I guess it depends. Maybe if you work in an office and there's a microwave oven that always goes off at certain times, then that might affect it. But what I will say is that the and I know that you know this well, but the RF environment is very dynamic. The tool itself, I mean, if the results change, it's not because the tool is unstable or because there's something about the Wi-Fi chip that, depending on the type of day, it's going to report different results. If it reports different results, it's because there's something in the RF environment that's different. One of the difficult things with configuring a wireless network is that things change. What if, it could be in an office environment, and you install a metal cabinet where there didn't used to be a metal cabinet. And so now, because radio waves bounce off of walls and metal and stuff like that, maybe you change the pattern of how waves bounce off, and maybe it changes the coverage. Maybe that room, now all of a sudden the coverage is, is poorer than what it was before. We know from testing, it's amazing how many changes you can make to a room that will affect a measurement. I mean, even you move an antenna, if you have an access point and you move it like a foot to a different location, you might get quite different results. And it's because of the way that radio waves bounce off of walls and the angles that they bounce off of walls. And just changing the location, or changing if an antenna is vertical and you change it slightly so it's maybe at a 45-degree angle, you might see a change depending on the room and where the walls are and what things it's bouncing off of. So things do change, and it's important to have a tool where you can monitor things. If for some reason the performance changes, you can bring out a tool to see if you can figure out why, and then correct it or to make a change.
Well, I have about the changes in the antenna is kind of a nice segue to move. My next question was about that cute little dual frequency antenna that comes with it on that little stubby wire. What is that antenna? It's kind of fun. I mean, I like it, but obviously you could have had lots of choices of antennas to put on there. Why did you come up with that one?
Because that's the one that Ariel Rojo, this amazing RF engineer in Spain, recommended. So this one, it's called a clover leaf. And what's different about it is that it also, so most antennas, if they're like a whip antenna, they're vertical, and their field, it's like a donut around the antenna, right?
The standard dipole, yeah.
But what about stuff above it? Or what about stuff directly below it? It doesn't detect it. Okay, but with a clover leaf, if you were to open it up, or actually, if you were to Google cloverleaf, they have all kinds of fancy design. So the reason we chose that one was twofold. One is that in a single antenna, it's a dual band antenna. So that was the main thing. The other thing is that because of the cloverleaf shape, it will also pick up RF above and below, in addition to the donut. And actually, there was a third one: is the cost. Is that it's a reasonably priced dual band antenna.
So what's the dBi of that antenna?
I think it's 5.
Oh, so not only does it go in all directions, it's also going quite a distance in all directions.
Yeah, it does. It does have the ability to amplify.
Well, I sure appreciate your time today talking about Nuts About Nets and your Wi-Fi Metrics product. If someone wanted to get a hold of you, are you on social media?
So I don't do social media so much.
Well, you do have a website.
We do have a website. The website is nutsaboutnets.com. Actually, we have several websites. We also have one called rfexplorer.com if people are interested in a low-cost handheld RF spectrum analyzer. And we also have a website for wifimetrics.com. And we can be reached, we do email. Email is support@nutsaboutnets.com. And one day when I have enough friends, maybe I'll start doing social media.
Well, after this podcast, you'll have tons of friends who will want to contact you. Your RF Explorer, it's also small, handheld, etc. But you can also hook it up to things like Adrian Granados's Wi-Fi Explorer. Or you also have Windows software for it. Are you thinking about having a Mac version?
We have a Mac version. It's called Touchstone Pro for Mac OS. We also have an Android version. It's called Touchstone Mobile. And it uses I don't know if you're familiar, for Android, it uses a type of USB cable called OTG.
Yep. Uh-huh.
So we have Windows, Mac OS, and Android software for RF Explorer.
I mean, the little screen is fine. I mean, I have one. I like it. It's quick and fast and easy to get out and do a quick test. But that, a small LCD is really tough to get any kind of granularity. And yet the data is in the box, so you just need to, hook it up to a bigger machine and take a look at it.
Yeah. Our RF Explorer has been a great product for us, and it's because the software really adds, the PC software really adds value, because now we can do all kinds of charts that makes the data more visible and helps people, see what's really going on.
And as a person who actually developed and coded the software for a spectrum analyzer, perhaps for our listeners, you could explain how spectrum analyzers have, depending on who you're comparing to, higher resolution, so they can see. Let's just pick something like a Bluetooth single frequency hopping spike. What do you need to do software-wise to be able to see those?
It depends. We used to write software for Signal Hound, and they would have, and when we needed higher resolution, we were dependent on their APIs, and it was sort of difficult. With RF Explorer, when it does a scan, and regardless of what the frequency span is, whenever it scans from a start frequency to an end frequency, it gets 112 points. Okay, and that's just the way it works. So if I was scanning from 100 megahertz to 212 megahertz, I would get 112
slices. Yeah.
Right. Okay. And for some applications, might be good enough. Other applications, it's not. So how do you get higher resolution? So what we do is that we can program it into doing many subscans. So even though the user may say, I want to scan from 100 megahertz to 212, what we may do, we can program the device to do one subscan from 100 to 101, and then from 101 to 102, and from 102
and get
to
112
103.
slices inside each of those.
Right. And so now you can get finer and finer resolution. Although, like with everything in life, there's a trade-off, because the more subscans you do, the slower it gets. But to complete an entire scan. But this is sort of a little bit off topic, because oftentimes people ask, how come the scanning is so slow? And it's not that it's slow; it's just that in order to achieve higher resolution, you got to do more scans. And I would also add that, like, for most applications, like, fast refresh rates isn't as important as doing one scan with really high resolution. And like we know, like in the wireless pro audio field, what they will often do, they take one really high resolution scan, a week before the performance, and analyze the heck out of it to find out the best frequencies. They don't really need to have it scan 1,000 times a second, because for the most part, if there's RF interference, or if there's something going on that's going to prevent them from using certain frequency ranges, that's going to be pretty static. And whether and as you know, if you look at a spectrum trace, if it's 1,000 times a second, 999 of them are exactly the same. So what we concluded is that it's worthwhile to go for the trade-off, to go for higher resolution at the expense of faster refresh rates.
Well, thank you for answering the question. No, that was what we're looking for. So, what's the future hold for Nuts About Nets?
What do you think the future of Wi-Fi is, Brian?
I think it's doing pretty good.
So I think we're also excited about IoT, because I think that as more and more Wi-Fi devices flood the market, from a diagnostic standpoint, I think that the future looks bright for us, because Wi-Fi is becoming more and more popular. There's going to be more and more devices out there, and there's going to be more. There's going to continue to be a need to troubleshoot how come something doesn't work.
So we all need tools.
So yes, we do.
Well, Steve, thank you for your time today. If anyone wants to look at some of your professional and yet still affordable tools, nutsaboutnets.com, right?
Yes.
From there, you can go to Wi-Fi Metrics and or rfexplorer.com. Well, thanks for your time.
Yeah, Keith, it was a pleasure. Thank you so much.
Thanks.
Wireless LAN blog reviews with Glenn Cate.
Glenn Cate, welcome to the show. What Wi-Fi blog review do you have for us this time?
Hey, Matthew, good to talk with you. And I'm excited about reviewing a blog site that's done by a newbie. You don't have to be a Wi-Fi veteran to do Wi-Fi blogging. You can be a newbie as well. And we're going to be looking at nolanwifi.com. That's NOLAN Wi-Fi.com. Nolan Herring is the author. He's CWNE number 198, and his Twitter handle is at Nolan Wi-Fi. Kind of does a play on words of no LAN, no local area network. Ha ha, laugh, laugh. Anyway, I've worked with Nolan in the past at a VAR, and we just love going out and talking tech stuff over dinner. The time just flies behind us. And he started a website, and I really like Nolan Wi-Fi. As I'm looking at his website right now, Nolan is probably the meme meister. He cannot do a blog without putting a movie meme in there. And so on his first page, he says, "Can't stop the signal, Mel. which is from the Serenity movie, if you've ever seen that in the past. And honestly, his memes just get better from there. He's got on his main page, he has a topic, Meraki's Mesh Mess. I can't say that 3 times in a row, but it is funny about how Meraki access points and how they have this mesh network and talk to each other, even though they're plugged into your PoE switch. And Meraki Mesh, so easy a caveman could do it. So you're going to have to check out his blog site and look at the memes because they just get better from there. But he's got some great material. I looked at his website once when I was trying to hook up my GPS to Ekahau to do outdoor surveys. He's got that on his website because he went out and figured out how to do it and blogged about it. So he has got some great stuff in there. I like his website because it's just very clean. It's attractive. It's easy to use. Great colors and backgrounds. So Nolan has done a lot of time and made it very pleasing to use. It's just not white text on or black text on a white background. It's got some great stuff in it. And of course, the appropriate meme. He cannot do a blog without a meme there. So it's a lot of fun. So you're going to love it.
That's great. Anything else we don't want to miss on the site?
Okay. Well, one thing that he has done, and this is just a neat thing that he has done on one of his blogs, he's done a spectrum analysis kit where he's kind of put together a layer 1 analysis with a Cisco access point running autonomous mode, but he tells how to put it into spectrum mode, and then you can use Metageek Channelizer. Some of you guys know how to do that, and you can get the resolution. You're probably familiar that Cisco AP uses the Cognio card that's built into it, and it just gives a much higher, cleaner resolution. And so he tells how to do it, how to use the battery backup for the AP. He even gives the CLI code in there, how to get the access point change from regular to spectrum analysis mode. And so you want to be sure to check out the spectrum analysis kit that Nolan has on his Wi-Fi site.
Thanks, Glenn. And we can follow you on Twitter at GRCate. I guess until next time.
Hey, this is Glenn Cate, and wanting you all to know that keep on blogging in the free world. Bye for now.
10 Talks.
So hello, everyone. Thank you, Keith, and the group for fitting me in. I was being pressured by some of my colleagues here, and then after Alan's talk on sharing and whatnot, I think it just was fitting to say a few words. I'm from the U.S. I'm very grateful to be here. It was kind of a coincidence to be in Europe and being able to attend this conference. And for a couple of reasons. One, I see that it's a pretty young group when it comes to kicking off your wireless career and starting down a more serious certification path. That's very exciting to see and very exciting to hear when most of you have presented and to talk to you and get an idea of where you're at and the excitement. It's very, very, very refreshing compared to some of the groups in the U.S. They're bigger groups and a little bit more seasoned, and it's good to hear a more refreshing conversation. So thank you for that. And that kind of also inspired me to say a few words today. I was kind of struggling with topics or whatnot, but I felt like what I've done in the last 10 plus years, more than anything, and just more talking to the young folks, something else you have to prepare for besides all your exams and all the other things you must do to go down that CWNE path is you must become a coach, right? So, and when I say coach, one thing that you're going to do more than design, implement, troubleshoot is you're going to have to educate. Wireless is one of those topics that touches people across all verticals, across all industries. So you can't get away from it. You have to, and when I say educate, I'm also talking about non-technical folks, right? Because we all educate each other, we educate our customers and whatnot, but we really have to get serious about educating our peers and our other folks that are not necessarily technical or in Wi-Fi, and you'll start to find that not only will that accelerate your growth in the wireless field and as a professional, but it'll also open doors and remove barriers for you. And I think that's also the essence of what the advisory board is trying to do. We're trying to get the word out, and I'm not part of the advisory board, but they're trying to get the word out, and they're trying to align our groups so that we could start to make best practices more official and whatnot. That's at least not my understanding. And I believe that one of the paths to doing that is just a broader sense of education across all verticals and all people that we deal with. And so I've kind of taken that on in previous jobs and found that to be very rewarding, because who are we coaching? Like we said, everybody, right? There's nobody that gets left from this list. Sales teams, our bosses, how many people needed permission to come here? There's more than just budget. Sometimes you have to convince them that it's technically valuable to the company that you work for. IT departments. I mean, there's a wireless guy at every customer IT, but they're not truly a wireless person, right? They've touched a controller, they've worked with a couple tools, but there's always a continuous education that has to be completed. And so this is more inspirational to kind of broaden your radar when it comes to when you're encountering different groups to take on a challenge to start to make them aware. So I've kind of hacked a couple of slides together just to show you some of the things that I've used in the past. Wireless is not easy. I mean, if you're in this room and you're down a path to get certified, and then I could tell you right now, you already know more than most people out there about wireless, regardless of your certification. And that means a lot, but that's because wireless is not the easiest thing to understand. And when you look at our landscape, this is kind of what we're dealing with internally, right? As a professional, I mean, the real world is this sliver, and then we have all this other stuff that kind of influences what we're trying to make the real world. And so that's hard to get across to folks that are not in our field. And so, I always start off with this slide when it comes to a group that's non-technical, and just go over the misconceptions right off the bat, right? The biggest one, home Wi-Fi is not the same as X. It could be hospital Wi-Fi, it could be warehouse, it could be, you name it, enterprise or small business or higher, and it's not the same as your home. And that's a huge misconception that people have. And when I put this slide up, we spend about 10 minutes just talking about some of the things on this slide because of how the rest of the world or the common person that's non-technical sees Wi-Fi, right? It's not all wireless is the same. Our broadband cellular connections are not the same as 802.11. Wireless devices are created equal? Hell no. And single strength bars, right? Just all the things that we know as professionals in this field, educating just nuggets of information make a huge difference when it comes to clinicians or actually nurses have been the best at adopting some of this stuff, just FYI. But it really just comes to thinking about breaking this down for our peers that are non-technical. And if you follow that path, I guarantee that it will make your job easier going forward. So I'm going to scan through these pretty quick, just examples that I've used to try to get the point across that, we're dealing with an invisible technology, right? Where there's no wires that I could point to. I got to show them either a screenshot of air magnet or a spectrum analyzer, which does no good to somebody who's not trained. So we have to start to just really get easy and fundamental with some of these folks. I mean, you're trying to explain this, right? to a person that's non-technical. Even to a wireless person, this can be difficult. So, you have to kind of take a step back and really dial it into what makes sense and what will help them to kind of understand why they need to hire you and not the guy who's cheaper, right? And really understand why you should be going to conferences and keeping up with the technology, because it is more difficult than it seems. And yeah, why does this work? Because it's super fast, right? That's the only reason. Explaining standards, right, and protocols, you really have to make it simple because it's so easy to get lost in the weeds in our field. So just continually trying to break this down. I always work on these slides with different industries or groups that I'm working with, just to make things a little bit more simplified. You know, it's invisible. How do you explain duty cycle to somebody, right? When it's an invisible technology or capacity. It's just, you have to get visual. You have to really break it down for these folks. But again, I guarantee it will make a difference. And then just educating our customers who have vendors and other folks that come in and say, yeah, look at, you got perfect coverage, right? We have to educate them why that is different than that, and why our laptop is different than our client device. Just simple things, and really becoming that teacher, and becoming a good teacher so that you're not coming off as, you know, a know-it-all. I'm not saying to do that, but you really have to hone in that skill, just like we're honing in our wireless skills. And so, you know, RF interference and things of that nature, you really have to just kind of break it down when it comes to devices, body attenuation for medical devices, polarization, orientation, all the things that all of you have talked about today. We have to kind of sum it up and package it for our folks so that they can have a better understanding of what we're trying to do, and understand why we cost more money, or why we need to do certain steps that other vendors might not do, right? Oh, well, I didn't need to do that with so-and-so, or, you know, CW, somebody didn't make me do that. And so you really have to break it down. So what you could do today, you're already doing this, right? You're here today, you're involved with the wireless community. Get certified. It makes a difference. Stay certified. You know, don't let that lapse. In this path, it only gets harder. Like I said, you got to become a teacher. You got to keep up on your certs, and you have to do all those things all the time, and work and have a family. So a wireless engineer to me is a multitasker beyond some of the other folks that in our fields. But diversify yourself too. I love designing. I love working out in the field and taking on more challenging environments. But I've been in the client side for the last 5 years, and I really enjoy it, and I really see the benefits of being on the other side of the coin. So don't be afraid to do that. I mean, wireless is not going anywhere. You could definitely go back and forth whenever you need to. Act and look professional, right? That's going to make you a better teacher. That's going to make you more respected. And again, going back to ABC, always be a coach. You know, just like we're studying and we're doing all these things for our certifications and we're building our labs at home, build your slides. You know, ask to train and teach a subject at all meetings. You know, invite yourself to sales meetings and things like that so that you could start to educate those folks. I know that some of you guys are getting your sales team, CW, TS and whatnot, and that's the right path. And again, if you're in this room, I guarantee you're probably more versed in wireless than most folks out there. So be the expert and hold yourself out to do that. And just make basic wireless training part of any cross-functional project before you kick off. It makes a difference when they understand where you're coming from. And one thing we tried with the last company as I was at is a day in the life of blank. So we had a cross-functional team. I was working for a medical device company, and what we did, everybody wore somebody else's hat. So I became a clinician for an hour. Then the clinician became a wireless person for an hour, and I forget what the other folks were doing there, but we switched roles. And you had people walking around with their magnet, doing site surveys, looking at spectrum, and it makes a difference. It makes this thing make sense to them at the end of the day, and it just drives things home. But I guarantee that this is just one more thing you have to do. I'm sorry, I know you have a lot on your plate, but make teaching and make yourself a good professor, so to speak, of the craft, and it will definitely make your path a lot easier. Thank you.
Thank you.
Divergent Dynamics with Devin Akin.
Today we're going to talk about proving a design. My customers often want me to design and validate, but rarely to deploy. They often leave the deployment to value-added resellers who specialize on specific types or manufacturers' gear that they specifically sell, and sometimes they leave it to their own internal administrators to do the deployment according to the design document. After delivering the design document to the customer, along with all the supporting documents, I will expect a call after the deployment requesting me to validate the network design and deployment. There are many important steps to a validation. For example, performing a site survey and adjusting for minimum co-channel interference on each band if you're deploying both bands. At least 25 dB SNR in pretty much all areas. Looking for appropriate overlap to support roaming, appropriate secondary coverage if your RF redundancy is needed, and of course making sure there's no coverage holes in mission critical areas. You may want to do a manual validation prior to using RF site survey software as well, using mission critical devices. For example, if you're in a school, you may want to walk the circumference of each classroom with an iPad looking for co-channel interference, where there should be no other APs on the same channel with the AP that's in the room where you're currently walking. You're going to want to test your top 10, that's what I call it, the top 10 list of mission critical devices to see if, number one, there's adequate throughput in a real-world live environment to adequately allow your applications to work. In other words, they have to work properly. If it's video, it should be streaming smoothly. Audio, same thing. Of course, if you're copying files, make sure that it's fast enough, to support whatever you're trying to do. Number two, roaming is working properly during mission-critical application use. Specifically pay attention to client channel support in case some of the clients don't support all the channels that are used in the design. You would hope that this would get caught during the design phase, but it doesn't always. And then another is to check the channel utilization, the retries, and any voice characteristics for voice-enabled environments like latency, packet loss, jitter, MOS score, and so on. All of those should play right in. The most important of all of these is to check the actual devices that will be used, that top 10 list, if you will, of mission-critical devices, to make sure that they are connecting properly, roaming properly, and the applications are working properly on them to the taste of the customer. If that's not done, all the design in the world is not worth much. And lastly, go back to the design document and validate that all of the design requirements are met before leaving the location. Thank you.
Tools review.
Next up in our tools review is a quick little one called LAN Scan Pro. LAN Scan Pro is a simple and efficient IPv4 network scanner. It goes and discovers all active devices on your subnet. You configure it. I normally use it on my local subnet, but you can configure it to go just about anywhere. It's fast, it's efficient, and it does a really useful job that just lets you see the devices on your network. I've used it in the past to document up and learn what devices are on various lab networks. I even use it on my home network. It's simple, it's quick, it's really efficient, and it has a bunch of columns. The columns are, what you'd normally expect in a scanner: IP address, MAC address, host name. But it'll also do a UI lookup on vendor name. It'll go and search your DNS name, your MDNS bonjour name, SMB names, SMB domains, and if you even want to, it has a file that will save. If you want to write comments on each of those, you want to remember, oh, that's my, something server is at that IP address, so you can remember later. Any of the columns that shows up are sortable. Makes it easy to organize the information you get off your network. You can configure it to set a customizable set of network addresses, and the best part is you can export it and then bring that data in something else to do better documentation. This doesn't do anything you can't get with other tools, but I use it all the time because it's in my dock. It does it fast, it does it accurate, and it works every single time. So I really like LAN Scan Pro. It's brought to you from the same guys who do Dabuki. This app is only $5.99. You can get it in the Apple Mac Store. There's a link in the show notes if you want to give it a try. Thanks.
Wireless LAN terminology.
Beacon. These are frames sent from the AP to the clients on the wireless network that keep the network synchronized. Also produced by non-AP stations in an IBSS. It signals the availability and presence of the wireless device.
Well, we made it to the end of episode 110 of Wireless LAN Professionals podcast. Thanks for listening. We covered Steve Leytus of Nuts About Nets on his Wi-Fi metrics tool and how they developed other tools. Interview from Cate. a little bit from Devin Akin. We also had a little 10 talk from Adam Vasquez and a tool review this time around. Thanks for listening. Again, we appreciate your, if you liked the show, leave comments. If you really liked it, go on to iTunes, subscribe, and, give us 527 stars, something like that. Stars always help. Thanks for listening. We'll see you next week.
Thank you for joining us for another episode of the Wireless LAN Professionals Podcast, the podcast for wireless LAN professionals by wireless LAN professionals. Be sure to follow us on Twitter at Wireless LAN Pros for all the latest news and updates, and also connect directly with Keith on Twitter at Keith R. Parsons. Head over to www.wlanpros.com for this episode's show notes, as well as the latest in all things Wi-Fi.